Welcome to part 2 of Competency 9. In this video, we will work with triangles and angle measures. Number 1, what is the measure of BDA? All right, let me mark that. Okay, this measure right here, they're talking about this. Okay, all right. BDA, if BDA is 10% less than twice the measure of CDB. Okay, CDB, I'll use a different color here. That would be this one. Now, you need to think of it like this. If they're using another angle as a guide, like using it in this words, 15 degrees less than twice the measure of this angle. That means that this second angle is like the original angle, the one you're going to play off of, okay? Then we can write the rest of it, or rather write the other angle, okay? So that's twice, so that would be 2 times x, and subtract that 15 degrees, okay? Now, we know that any straight line has a degree of 180, okay? And that these two angles together are supplementary, meaning that we add them together, they're adjacent along a line, so we can just add those together and it equals 180. So this is what we have. 180 equals 2x minus 15 plus x. Okay. Now, there's a couple ways to look at this. We can solve this and go through all the manipulations. Okay. Now, remember, we are trying to find the full measure of this angle. Okay. The BDA. So let me mark that. We're trying to find this guy right here. Okay. This angle. But before we can have success finding the angle, we need to find x. So that's where we are right now. We're trying to find x. Okay. Yeah, you could go through all the manipulations. However, we've set it up. For accuracy purposes, let me put this in the table, okay? And I say that because I want to put the right-hand side in the table in our calculator, and then I'll look for this measure to equal y. Okay, so I'm going to say y equals 180. So if you watch the other videos with me, you know what I'm about to do. So let's do it. Let's go table. Okay, now see, I have something else in there, so clear all that out. We're going to say 2x minus that 15. That's what it gave us to begin with. But then I'm going to add the other starting angle, so plus the x that we use as our guide angle. I call it guide. That's really not. It's like the original angle is x, and then they're just feeding off the other one. Either way, doesn't matter. Doesn't matter. We have a good setup, okay? Now, we are saying that we're looking for the 180. So that is going to be our y, okay? All right, think about it. That would make sense, okay? So we have the right side of our equal. We have it in the calculator. Now we're looking for the left side. Okay, so push enter. All right, now remember, we can't use ask because the angles that are given in our ABCD options, those are all for this guy right here, for the angle that I have highlighted here. Okay, right now we're just looking for x. Okay, so let's say 0. Go down, go down. We want it on auto. Okay, now look at how it decreases pretty quickly. So what we're going to have to do is arrow down till we find 180. Okay, all right, let's do it. All right. And you're like, well, that's going to take a while. Yeah, it does. However, even though it takes time, you could manipulate. The difference in manipulation and using the arrow down, which we have, okay, we found it. The difference is The calculator has accuracy. You could make mistakes while manipulating, and you are trying to pass a test. For teaching, I wouldn't do this. For testing, yes. You are trying to get your certification and move on. Okay, so we have that x equals 65. Okay, so that would tell me not to select A. Okay, now I want to show you something else. Now, what if we had done it differently? Let's say we started with our manipulation. Okay, here, let me subtract, or rather erase some things, redact some things here. Let me show you what I was talking about. I'll come over here, and we are saying that x is equal to 65. Okay, now let's say we took this a little bit further and did it slightly different. I'm going to say minus 180 on both sides, okay, which makes sense to you. Okay, so this will go away, but that leaves us with y equals 0 and then equal to the rest of this. So let's do the rest of it. Okay, let's do that side. We have changed the right-hand side. So clear, clear. And let's go over here and say minus 180. Okay, so now what do we look for? I'm going to put 0 here. Now we look for 0, y equals 0. Okay, so we've got it all set up. We don't want to ask at all. So we keep going down, arrow down, okay, until you get 0. And notice it goes down pretty quickly, but you're still, either way you do it, you're still going to end up arrowing down. But again, as I said, this is about accuracy. Okay, again, this verifies x equals 65. Okay, it doesn't matter which way we did it. We know that our x, that's what it is. So now what do? We simply go and substitute, okay, for that angle. All right, so go second mode to back out of all that and say 2 in parentheses our 65, and then just subtract the 15, and there we go, 115. So B is a valid answer. Now, before you move on, and I say it's a valid answer, don't believe it quite yet. You need to add 65, your x, your adjacent angle, okay? All right? And it better equal 180. And it does. If it doesn't, that tells you you've made a setup error. You have seen something wrong. But notice I have minimal computations, and that means I've minimized my errors and mistakes. When you are testing, you get tired and the clock is ticking. You only have about 3 minutes per question. That's not a lot. Think about it. Even with the arrowing down, I still can get through it. You know, my 3 minutes were utilized properly, and I go to the next question. Okay, that's why I do some of these things on the calculator. It's all about testing. I would never teach this until I wanted my students to be able to pass a test. Okay, show them what to do properly, go through the motions. That's your job. Then, when you say, okay, guys, I know you understand everything. Now let's add this calculator piece because the clock is ticking. Okay. All right. Now let's talk about, actually, I need to go up. I remember this question. Okay. Let my computer catch up. There we go. It says, how many acute angles have vertices at either B or E? Okay. All right, let's do a little bit of getting rid of some of this. Okay, now they're saying B or E there. E or B, B or E. Okay, let's talk about B first. B is sliced into two angles. And what they're doing is they're trying to measure your knowledge of the word acute. Acute means less than 90. Well, B is 90 degrees, okay? And I see 1, 2 angles. So I'm going to say 2, okay? Now, let's go to E. E, if you look at E, we're talking a line, a straight line. We don't have a nice 90 degree. We have 180 degrees. Well, obviously, when we look at that, you have two adjacent angles, and only one of them at E is going to be acute. They just want to know that you know this simple vocabulary. Acute is less than 90, and in this situation, it's very easy to see at E that we only have one. This implies three angles. That is just a quick, do you know this? And you may say to yourself, well, that seems like a not a very rigorous question. Oh, you may be asked some of these within a question about a student. A student says there are this many angles. What mistake has the student made when regards to the number of acute angles? Okay. So it may be as simple as saying, well, the student, they give you all these long answers and you've got to know what to tell the student and gauge what the student did wrong. And in this case, probably what a student saw wrong was they were just counting all the angles and they didn't know what supplementary and complementary was and acute and obtuse. Okay. And so this kind of question has validity. Okay. Even though it doesn't seem rigorous enough, you still need to know it because it will be embedded within more complex situations. Okay. Let's move on to number 3. Okay. Number 3. If two sides of a triangle are 7 and 9, what are the possible integer lengths of the third side x? Okay, so what do we really have here? We're going to have a triangle, and we're going to have 7 and 9. Okay, at this point, we need to really look at a good visual. Okay, so let's take a look at GeoGebra and move this around and see what we actually, how we should view this. Okay, so notice we have 7 and 9. Now, I want to have you focus on A to C as 9 and C to B as 9. We will move B, okay? And notice I'm going to try to keep that 9 above. Now, look at the base, the bottom. That's 10. So we know 10's okay. And I'm going to move up, but I'm going to focus on keeping that 9, okay? Oops, I didn't. There it is. Okay, notice I have 12. Okay, and I'm going to keep going, keep going. And as I keep that 9, I know it's going off the screen. Okay, here, I can move it. Let's go this way, okay? All right, now notice, oops, back to 9. I can have 15, but what's going to happen if I have 16? Okay, oops, I'm kind of messing this up. If I have 16, it's flat. So that's no longer a triangle. So that tells me I have to have x to be less than 16. Okay, so we're looking at that, 16. Now let's go back. As I keep the 9 and it turns to 14, okay. Oops. I need to go back to 9. Okay, we can have 12. Now, oops, got to keep the 9. Got to keep the 9. I'm going to move this up. Here, let me go up. Now, I know that I can only have a max just under 16. What about a minimum? Well, watch the 9. Watch the 9. We got to keep that 9. Notice I haven't moved 7 at all. As I keep that 9, I have 3. See how the 3 changes? And I have it, and I keep it, and I keep my 9. So I can't have 2. So once I get 2, 2 plus 7 is 9, and it flattens again. So it looks like I have to have a number greater than the 2, but less than the 16 to maintain that triangle shape, to actually have a triangle by definition. Okay, so let's go back and look for our answer. So now we can look at our options. We know that something just greater than 0 won't work as a minimum, and the max has to be less than 16. So no, B's not valid because we saw as we move the triangle around that that third line could be like 3, 4, 5, okay? And looks like C is what we need. D just isn't valid because once we move the triangle around, you saw that. And also, this is a property that we read in, or it's was part of part one. We went through it in part one, not in depth, but now you've seen it in depth, okay? All right, so let's look at number 4. In triangle RST, if the measure of angle R equals 72 and the measure of angle S equals 29, which side is the longest? Which side is the shortest? This is also a property that we read in part 1. So you might want to go back and look at that if you didn't watch that video. Okay. However, I have put a triangle, a blank triangle in here for us to use. Okay, so if we say that this is R and this is S and this is T. Now I've labeled those according to the property and the degree measures. So obviously S is the smallest and that's 29. Okay, and then they gave us R and that is 72. Okay, so across from S, we would have to have the distance of S. And across from R, we would have to have that distance. And then across from T, that would be a little t. Okay, now we use our calculator and figure out what the degree measure of T is, which is also a property of a triangle. All three angles have to equal 180. So that's 180 minus 72 minus 29, which would equal 79. So you put your 79 degrees in here. Okay. So now we know what is the largest and smallest. Obviously, S is the smallest. Okay. So where it says shortest and it says anything else but T, we mark, I'm sorry, S. We mark out where it says T. So we know it's got to be one of those. Now, who is the longest? Well, whichever degree is the largest, which is T, that's at 79 right here. You go across, and that has to be the longest, and that is T. And that, of course, gives us option D. Okay? All right, those are all the properties kind of well, some of the properties. It's some properties put together all together. Now, you may not get a triangle like this where it's labeled. You'll have to label it all yourself, okay? All right, so let's look at number 5. Using the figure to the right, okay? KL is equal to 4. Okay, so this is 4. J or HJ is equal to 8, all right? And HK is equal to KI. So let's see, HK is equal to KI, okay? Which or what statement is true regarding the figure? Okay. All right, here's the thing about this figure. All right, move this around here. Here's what's going on with this figure. You would be very tempted to say or invoke that they're parallel. That would be here. These two lines or segments, the KL and the HJ. But you can't. You cannot say that any of those properties from part 1 that we went through and talked about briefly, okay, and we've used before now. You cannot say that, and I'll say why you can't imply any of them. This segment here, I, L, and L to J, they would have to be congruent. And without those little congruent marks that I have just added, or words, saying that they're equal or congruent segments. Without them, it does not apply. And because of that, we cannot accept A, we cannot accept B, we cannot accept C. We have to say there is no relationship between the length of KL and HJ. Although it looks like there is, they've given us information. The problem is they didn't give us enough information. And that's what you'll have to pay attention to in any test you take. That is a very obvious thing to ask to see if you thoroughly understand the properties, axioms, and thus, and you understand what makes something parallel and how simply moving, if I took K right here and I moved this up, it would have to go up. I moved this line up enough, I could get it to equal 4 again. There is a way and it can be done. And that would equal 4, and that would just debunk this whole estimate here. Okay, or this picture may not be drawn to scale. That could be a truth. So be careful jumping to those conclusions. It can get you in trouble. And this particular question is a huge warning against that. Okay. All right. But a very excellent question. It's a great question. And it helps you like pull back and remember all of those things you learned in Euclidean geometry. Okay. This is the last question in this particular video. I wanted to thank everyone for watching again. You're amazing to watch it all the way to the end and liking and sharing us. And kudos to everybody subscribing. You are keeping us online, keeping us available and free for everyone out there. Happy testing, everyone.